good morning, good afternoon, good evening. Welcome to the Next Genius webinar series on what to study at college. I'm Helen Thomas Ilinikil, and I'm the communications expert at the Next Genius Foundation. Today, we have here with us Katie Cadwell. We welcome you, ma'am, to the Next Genius webinar series on what to study at college.
Hello, thank you very much.
Thank you, ma'am. Giving a brief introduction about Katie Cadwell, she is the Associate Teaching Professor, Chemical Engineering Undergraduate Program Director at Syracuse University. She has completed her bachelor's and PhD in Chemical Engineering. She is the postdoctoral research associate in STEM Education and Outreach, Interdisciplinary Education Group, Materials Research Science and Engineering Center, University of Wisconsin-Madison. She is also the chemistry instructor, general chemistry coordinator, and engineering transfer program director at Madison Area Technical College.
I'm sorry, I need to interrupt. I am not those things any longer. That was previously.
Oh,
so those were before I came to Syracuse.
So moving on to the teaching interest of Katie, her interest lies in engineering and computer science, mass and energy balances, chemical engineering thermodynamics, chemical engineering laboratories, technical communication and professional skills, and also chemical process safety. So giving a brief introduction on what we are going to deal with in this session, we'll be having a brief introduction to the course structure of chemical engineering, what are the subjects covered, the latest trends, and the career options once we graduate from chemical engineering. So over to you, Katie. My first question is, what is a major in chemical engineering and what is the structure of the academic curriculum across the 4 years? So you can discuss the academic overview of the program while sharing the general structure across the 4 years and the popular courses.
Okay. Well, like any engineering program, we are initially grounded in math and sciences because math and science are tools that all engineers use in order to make things. And for chemical engineers, hopefully, obviously, chemistry is one of the more important tools that we tend to use. And so in general, in most chemical engineering programs, including the one at Syracuse University, the first 2 years of your classes are heavily focused on mathematics, that's mainly calculus, as well as sciences, and so physics and chemistry, primarily for chemical engineers with a heavy emphasis on chemistry. And then you get a couple additional courses in things like social sciences and humanities and writing, because we like to be very well-rounded as engineers and not just stuck in math and science. And you do get a couple introductory engineering courses those first couple years as well, including my absolute favorite course, your second year, and that's mass and energy balances. And the class is about exactly what the name is. We balance mass and we balance energy. We make sure we keep track of all of it all of the time. And then in the third year of the program, then it becomes very, very engineering heavy because you have completed that mathematics background and most of the chemistry background, although you do continue to take chemistry through the junior year as well. And then kind of finish out with what we call the capstone courses. So those finishing off courses in your fourth year in chemical engineering. And those are courses that not only require the science and math tools, but also the earlier chemical engineering tools that you learned in your second and third year. And so it's very structured because we keep building one class on top of the other. So you have to make sure that you are really learning in every single class because you're going to need all of those tools later in the program. Whoops, I think you're muted.
Really sorry. That's perfect. So we got an idea about the course structure. Moving on to the second question, that is, what are the concentrations within this field?
So chemical engineering, like a lot of the other engineering fields, is actually very broad. And so chemical engineers can be involved in lots of different industries. We need to build up at least at the start, a lot of those different engineering tools so that you're ready to do all kinds of things when you go and get a job. So some of the core courses in chemical engineering have a lot of overlap with mechanical engineering. So chemical engineering sort of originated from mechanical engineering back when mechanical engineers realized they were going to have to work with chemicals. And so we have that extra focus on how materials behave and how we can make them do what we want them to do. And so some of the ways we think about how materials behave and how we make them do what we want them to do is we study things like transport, similar to mechanical engineers. And transport is, how does stuff move around? And that could be, how do fluids flow? It could be, how does air flow over an airplane wing? The mechanical and aerospace engineers tend to care about that a little more than we do. It is also, how do things mix and diffuse? So in chemical engineering, we want to do a lot of chemical reactions, and you actually have to mix chemicals to do that. And it is a tougher problem than you might think. Yeah. But also, how does energy move around? So how does heat transfer is very important to both chemical and mechanical engineers. And then we're also interested in energy and how energy and matter interact together. Because we use energy in order to get stuff, matter, to do the things we want it to do. And then sometimes we take matter and try to get energy out of it. And so that field is broadly called thermodynamics. And again, both chemical and mechanical engineers are interested in that, just from slightly different perspectives. As far as kind of like going on into industry, there are tons of industries that hire chemical engineers. Because when we think about chemicals, what is a chemical? It's all matter. And so if you're making something, you are probably using matter. And so a chemical engineer is going to be involved. And so the largest sort of broad grouping of industries that hire chemical engineers are called the chemical process industries. And those include things like specialty chemicals that other industries will use to make things. It could be materials like plastics, rubber, paper and pulp industries, and other fiber industries like making cloth. So both natural fibers, but also man-made fibers. It could be things like soaps and detergents. It could be petrochemicals, so obviously getting all of the different sorts of fuels that we get out of petroleum, but also getting out all of the small molecules from petroleum that we use to make other things like pharmaceuticals. So also pharmaceuticals, personal care products, cosmetics, food and beverage is a really large industry for chemical engineers as well. Now, most of those specializations will happen after you graduate with your bachelor's degree. But there is an opportunity in all chemical engineering programs, including ours, to take some of those specialized courses, usually in your third and fourth year of college.
The opportunities are vast, right? It sounds really interesting to know about the opportunities available in the field of chemical engineering. Now I'm moving on to the third question, that is, this is something all the students will look up to, like everyone will be curious to know the answer to this. That is, what kind of students will do well in the field of chemical engineering, and what are some of the skills a student must possess or work upon to succeed in this major?
Excellent. So actually, you asked about chemical engineering, but I'm going to go ahead and say that the things that will predict success in chemical engineering are the same for all engineering fields. We have our specialty, so it definitely helps to love chemistry, because you are going to take a lot of chemistry classes, but you're not going to become a chemist. It is just a tool for us as engineers. And so otherwise, we're really the same as all other engineers. Mm-hmm. And the kinds of things that I'm looking for a student to be successful are, first, it's good to take as many courses as you can in secondary school in math and physics and chemistry. And if you take other sciences like biology or earth sciences, that's great as well. But also good communication skills are very important for all engineers, because you're not just finding things out, you have to tell other people about the things that you find out, and you have to convince them that you're right. And so communication skills are very important. Of course, we definitely work on those once you come to college, because we do want to make sure that you can communicate all of the cool problems that you work on. The same is for all engineers. It's also very helpful if you like solving problems and complicated problems. So not just things that you immediately know the answer to or you've memorized something, but a question or a problem where you look at that problem and it seems hard and that excites you. And you're willing to sit down and try and figure out what could possibly be an answer. And so some of the skills that students need to be able to do that is they need persistence. Because when you have a complicated problem, which are the kinds of problems that all engineers work on, you're probably not going to get the answer instantly. You're going to have to keep working on it. And you might get the wrong answer several times first. You might go down paths of thinking that are not going to work. And so you have to recognize that, wait a minute, that's probably not the right answer. And you have to change paths and you have to try something else. And so chemical engineers, all engineers, they have to be excited by complex problems, and they have to be willing to keep working hard on them and to persist through failure in the meantime. And so that's something that most engineering students have to learn how to do. They don't necessarily come into college being comfortable with failure because they've always done very well in secondary school. And so they have to learn, how do I be disappointed when I don't get something right away, and then say, well, I'm going to keep going anyway to get to where I want. That is a key skill in engineering.
Yeah, facing everything, taking it as a challenge and facing failures. I think it's not only related to chemical engineering, but any other field as well, especially
Yes.
in engineering. Superb, Katie. So you already discussed about the career options that are available in the field of chemical engineering, but uh, are there any other typical career options upon graduation? You can elaborate upon the typical jobs or graduate programs a student can pursue upon the graduation.
So for chemical engineers, most commonly, at least in the US, most students go and get a job after getting their bachelor's degree. I don't remember the exact number, but it's around 90%. So it is the vast majority. And most of those jobs tend to be in industry, although there's some number of students that will go into energy production after finishing their bachelor's degree, some that will go work for government. And so that could be in national labs. It could be like for the Environmental Protection Agency. It could be for the Department of Energy or the Department of Defense. About 10% of students upon getting their bachelor's degree go on to get a graduate degree immediately after graduating. Some of those students will get a master's degree in chemical engineering, which is, I kind of like to call it a bachelor's plus, right? You're getting just a little bit more of those upper level specific courses. And some industries like that for their chemical engineers, and others really don't care, which is why most chemical engineers just go and get a job right after their bachelor's degree. A small percentage of chemical engineers go on to get a PhD right after they graduate. And sometimes that means getting a master's degree in the middle, and sometimes it doesn't. That depends on the program. And getting a PhD sets you up for a different line of jobs. Most chemical engineers that go on to get their PhD still go work for industry, but instead of being involved in production down on a manufacturing plant floor and offices, they are probably doing research within that company. And they're not just doing the research, someone with a PhD is training to be in charge of the research at that company. And so if you know that you want to do research and you want to kind of be the person making those decisions from a very early stage in your career, then the PhD is the way to go. And then a very small number of chemical engineers who get their PhDs take the path that I did, or that some of my colleagues did, and they go and they be professors of chemical engineering. Most professors of chemical engineering actually have two jobs. They both continue research, so they're leading their own research labs at the university, and they teach classes. I'm actually what's known as a teaching faculty, so I do not do research. I teach like a double load of classes because I love teaching. It was why I came to get my PhD. I knew I wanted to do it. And then there's also some number of students who, after they get their bachelor's degree in chemical engineering, they go on to graduate school, but they take a side step. And maybe they go get their master's or PhD in material science because they found out through one of their elective courses that they really liked material science. Or maybe they go to physics or to computer science or to chemistry. I think I had a student a few years ago that went to oceanography. And so it's very easy with a background in chemical engineering to sort of decide that you want to pursue a related degree in graduate school. Oh, wait, there's one other thing I forgot. And that's that actually a lot of chemical engineers in industry, they end up on sort of the managerial track. So chemical engineers are very good at solving problems, including problems that involve people and money. And so it is a quite high percentage of chemical engineers that make their way up through the ranks in industry. And so some number will also pursue master's degrees in things like engineering management, or sometimes getting their MBA after they graduate with a bachelor's degree.
Great, Katie. So there are a lot of career options upon graduation in chemical engineering. It's great to know. Katie, we are coming to the last question for today's session, that is on the future trends. Could you comment on the future trends? Where do you think this major is heading? What are some of the latest developments? And what does the future, that is 5 to 10 years from now, look like for this field, this major?
So chemical engineering is already so broad, both in research and in industry, that a lot of what we're going to do is continue because we're already in everything. And so we're going to continue in everything. And at least in the US, if you go look at some of like the government prediction websites, they say that chemical engineering is on an average growth track. So as far as like number of jobs, we're never growing hugely because we're already in everything. And so when something new comes along, we go into that as well. But it doesn't tend to lead to huge growth, but we also don't tend to see declines in employment opportunities in chemical engineering. Around the world, in more developing countries, as their industry ramps up, chemical engineering jobs tend to ramp up similarly. As far as the types of things where we're going to expand more, you just have to look at where industry is expanding more. So pharmaceuticals is an area that has been growing recently for chemical engineers. And I assume that pharmaceuticals, biotechnology, health type things, chemical engineers will continue to grow in that as that field itself grows. Technology, things like computer chips. Chemical engineers don't design how your phone goes together, but if you want to make that chip, we figure out how to make that chip. And so that's another field where chemical engineers are going to continue to grow along with the field. But like I said, it's just as new things are discovered, as new fields grow, chemical engineering tends to grow with them.
Right. Thank you. Thank you so much, Katie, for this insightful session. I'm sure students who are looking forward to taking up chemical engineering in their future and even engineering would surely benefit from this session. Thank you so much. Before we close this session, we would like to have a final piece of advice from you on students who would like to take up for their graduation chemical engineering. Anything that you would like to share with our community of students who are doing their 9th, 10th, 11th, and 12th?
So I think a good thing to do if you're thinking about chemical engineering is think more about where you might want to take it. Are you interested in energy and sustainability and the environment? If so, don't just take the math and the chemistry, but also start investigating that path. If you're interested in materials, whether that's the traditional materials of paper and pulp and rubber and plastic, or if it's electronic materials or advanced new materials, kind of investigate that as well. Or if you're interested in things like pharmaceuticals and biotechnology and healthcare, kind of look for those things as well, because chemical engineering is so broad that you really want to try to identify, well, chemical engineering seems like a good way to go, but what is it that I'm going for at the end? Like, what is that thing that I want to specialize in using chemical engineering, so that you've got that goal that's going to help you get to graduation. I can't remember if I said it already. All engineering programs are tough. They are hard. And so you're going to have to work hard, and sometimes you're going to be frustrated. And so it's really good to have that goal that helps you to see that you can make it through those tough times, that if you work hard, you're going to be successful, and you have that goal at the end that helps you see why you're trying to make it through that path.
Thank you, Katie. It was really, we are really honored to have you, and we had really very limited knowledge on chemical engineering, but we got to learn a lot about the structure, the career paths that we can take, the subjects that are involved, like we have to, how hard it's going to be, and that we need to have a goal in front of us in order to take up an engineering, because it's going to be tough. So thank you so much for providing us with a lot of insights. I'm sure our community is going to benefit from this. Thanks a lot. Before we close this session, I would like to share about our upcoming webinar series with our students community. So this is on Profile Building Fair, and this is for classes 9 to 12. And this will be happening on Friday and Saturday, July 30th and 31st from 4 p.m. to 9 p.m. IST. You could directly go to the Next Genius Webinars website and go to the registration tab, click over there and register, and see you for the Profile Building Fair. It's going to be really resourceful for you all. Thank you, Katie. Thank you to all the students who are watching this session. Thank you.
Great, thanks.